In these problems, we're using a technique called prime factorization to reduce fractions. And it's actually a pretty handy technique. If you know how to get the prime factorization of your numerator and your denominator, you can use this other property that allows you to cancel numbers in fractions. As long as everything is multiplied on the top and multiplied on the bottom, then same numbers on the top and bottom can just cancel out, disappear. Let's see how this works. First of all, I want to do a prime factorization of both my numerator and denominator, and I usually like to do it with the tree method. So I start with 24 here, that's our numerator. You can say that's 6 times 4. 6 is 2 times 3, and 4 is 2 times 2. Those are all prime numbers, so there's my prime factorization. It's going to be 2 times 3 times 2 times 2. Now let's look at the denominator. We've got 60. So 60, that's, well, it's 6 times 10. And 6 is 2 times 3. And 10 is 2 times 5. Now those are all prime. So that's my denominator, 2 times 3 times 2 times 5. And what you'll notice here is I can cancel a lot of these. So the 2 and the 2, the 3 and the 3, the other 2 and the other 2. And what I'm left with is a 2 and a 5, and that's my answer. That is the fraction 24/60 in its simplest terms. And it looks like our answer is here. If you're looking over the answers before you did the calculations, you could probably eliminate a lot of these. These are not even prime factorization, so you could have narrowed it down to B and D right away if you wanted to. All right, let's try a slightly harder one. We've got some big numbers here, 432 over 540, and we want to get the prime factorization, and it's a little bit of a headache to do that, and you might want to pull out your calculator. The way I do this with even numbers is I just start dividing by 2, so I'll say 432 is 2 times, and let's see, that's 216, and then 216 is 2 times 108, and 108 is 2 times 54, and 54 is 2 times 27. Aha! Now 27 is 3 times 9, and 9 is 3 times 3, and we got it. That didn't actually take that long. So we've got 2, 2, 2, 2, and 3, 3, 3. So 4 2's and 3 3's. That's our prime factorization for 432. Now we need to do the same thing for 540, so let's give that a try. And let's see, that's 54 times 10. I could have divided by 2 here again, but I just find it easier if you can take that 10 out right away. 10 is 2 times 5, so we're done with that branch. And 54 is 6 times 9, so we have 2 times 3 and 3 times 3. All right, now let's line all these up correctly. So, and for 432 we had 4 2's, so 2 times 2 times 2 times 2, and 3 3's, 3 times 3 times 3. And on this one we have, it looks like 2 2's, 3 3's, and a 5. So let's do that. 2 times 2 times 3 times 3 times 3 times 5. Now, I see 3 3's up here and 3 3's down here. We're going to cancel those. I'll cancel these 2 2's with a couple of 2's up there. And what I've got on the top that's left is just 2 times 2, and on the bottom, 5. 2 times 2 is 4, so we have 4 fifths. And looks like our correct answer is C. So that's a little bit of work with prime factorization as a method to reduce fractions. My name is Larry. I'm a teacher at EdVision's Off Campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.